Hi guys, thanks so much for watching this little video lesson. We are going to multiply and divide radicals today, and we're going to have them in little expressions. You already know how to simplify square roots when they are perfect squares. You also know how to simplify square roots and cube roots when they're not so perfect. But now what we're going to do is learn how to evaluate radicals when we find them in expressions, especially multiplying and dividing. That's our topic for today. So just a couple of rules I want to go over before we try out some problems. You can only multiply the coefficients. Another one of those words, words that we need an explanation for. Anyway, coefficients are just the numbers in front of them. That's it. That's what a coefficient is. It's just a number in front of something that multiplies. So we're talking in that case of the example there on the board, 4 and 2. Those are coefficients. And we cannot multiply coefficients times what's underneath the radical. They're different kinds of numbers. So we can multiply the coefficients times each other, and we can multiply the radicands, which are the numbers under the radical. We can multiply them together. So in other words, on this example, 8 and 3 can be multiplied and kept under the radical, and the 4 and 2 will also get multiplied and kept in front of the radical. But here's the steps, and this is a slide that you're going to want to save, especially these steps. You're going to first multiply your coefficients, then you're going to multiply your radicands. Then we're going to need to simplify, just like we were doing in the earlier lessons. Use prime factorization and maybe work smarter, not harder, that little shortcut I showed you in the last video clip. When you're done with that, if you end up with another number out in front with the coefficient, you're going to need to multiply anything that you pull out from under the radical sign, and then completely simplify our radical. So let's do an example there. We have 4 square roots of 5 times 3 square roots of 15. So 4 times 3. I hope you know how to do that pretty quickly. Let's just do that. 4 times 3. Let me get my pen here, which is 12. And that is going to then be followed by the square root of 5 times 15. And I don't have you guys here to help me. I have to get my own calculator. Darn! One of the disadvantages to doing it this way, because I don't know 5 times 15 in my head. That is 75. Now, looks like a pretty good number there. However, 75 has a lot of factors, and we can simplify it. So let's do our factor tree like we were doing before. And what I want to do is do the smarter, not harder thing. And if you think about 75, think about the square root. What square roots, perfect squares? Think about perfect squares. What perfect square can you see in 75? And I can see that 25, 3 times 25. And 25 is a perfect square. We take that square root. What is the perfect square of taking the square root of 25? That would be 5. So we're going to put it out front with our 12. And what we're left with under the radical is just a 3. Now to finish this off, you're going to multiply your 5 times 12. I think I know that one. I think it's 60. And that is our final answer. Now, if at any time during this recording that you don't understand what I did or I went too fast for you, just rewind. So let's do another example. And again, we are going to multiply our coefficients right here. And then we're going to multiply our radicands. Okay, so first of all, 2 times 3, that's easy, 6. And under the radical, 6 times 2, which is 12. One more time, simplifying the 12. Again, looking for a perfect square in the factors. A perfect square is 4. And 4 times 3 gives us 12. So we know, now keep your 6, we know that if we take the square root of 4, we get 2. That comes out from under the radical. The 3 stays under, and when we're all finished, once we then multiply our 6 and 2, we have 12 square roots of 3. All done. Okay, here is one for you to do yourself. All right, now we've done multiplying. Let's step right on to dividing. This should be easy, right? Easy stuff. 32 square roots of 24 divided by 8 square roots of 2. So 32 divided by 8 is 4. 24 divided by 2 is 12. One more time, finding the simplified radical under there. 4 times 3. Again, looking for a perfect square, which was 4. So we take the square root of 4, put that out in front with our original 4. Okay, square root of 4 is 2. The number under the radical sign is our 3. Our finished answer is 8. Easy. Of course it is. Let's do one more. Let's do one more together. We've got 36 square roots of 24 divided by 6 square roots of 3. So 36 divided by 6 is 6. 24, divided by 3, I think it's 8. I hope. Nobody's here to correct me, though. That makes it tough. All right, in 8, factors of 8 are 4 and 2. And again, we get that wonderful perfect square 4, which gives us 6 times 2, because we took the square root of 4. Under the radical is still the 2. So our final answer for this one is 12 square roots of 2. So, one more for you to try. Oh, I have to move that. Darn. Those answers are too high. Okay, here's a problem for you to do yourself. And make sure you always choose the answer. I need to know what you understand before we move on. Last, please go to Unit 4, Lesson 7, and in Fish Tree, and do that lesson. If you can't get to that lesson, it's probably because you didn't do the first 6 lessons. So please go and do those. That is your assignment for today. That is where your homework grade comes from. And don't forget about the quiz that is in Sapphire for the first part of the unit. Thank you guys so much for watching my video, and I look forward to seeing you in class real soon.